How long would a day be if the Earth were rotating so fast that objects at the equator were weightless? Now this is a very short question, but the physics behind it is actually quite difficult. Now let's start with a picture of the Earth, and let me just label the radius here, the distance from the center to the surface, and then let's say we have a box on the equator. And normally, if the Earth was spinning the way it is now, there would be an Fg force that goes towards the center of the Earth, but the box isn't falling down towards the center of the Earth, so there's another force that's canceling out. If it's, let's just say it's resting on a table, and that would be Fn, and that is equal and opposite to Fg because the box isn't accelerating anywhere. But in this case, the objects are weightless, so there can't be an Fn. So instead, because the Earth is spinning, that means that spinning very fast, that means that the other force is due to circular motion. So it is Fc. And we know that Fc is equal and opposite to Fg if we want the box to be weightless. So now that we've established that, we can use these two formulas right here to solve the equation. So we take this and we put in Fc equals 4 pi squared Rm over T squared, and Fg equals big G big M small m over R squared. So from this we need to rearrange for T because we're looking for how long a day would be, and T is for time of one period. So T equals the square root of 4 pi squared. Oh, but before we do that, we can cross out the m's on each side, because if we divide both sides by m, then both m's disappear. So without the m, we have the rest, which is G big M. Oh, oops. So now, this is the hard part. We have to substitute all the variables for their actual number. So R, I put that in the question. It's 6.37 times 10 exponent 6 meters. Then that we cube divided by G, which is 6.67 times 10 exponent negative 11. I won't put the unit because it's very long. Then also M is 5.97 times 10 exponent 24 kg. So now all that's left is putting this into your calculator, and that would give you roughly 5,092 seconds with some more decimals, but I won't put that there. And this doesn't tell us much, so I think it would be better if we change this into hours or minutes. So in minutes, we just have to divide this by 60, and that gives us 85 minutes. And if we want this in hours, it gives us 1.41 hours. So that would be a very short day if objects at the equator were weightless. And yeah, that's all. That's the answer. Thanks for watching.